This is a video for AQA Further Pure Mathematics, Matrices section 3.4, finding the inverse of a 3 by 3 matrix. Well, before we can go on and finally define how we find the inverse, we need to have one more definition, and that is of the transpose of a matrix. Now, the transpose is found by simply swapping rows and columns. So you can see what was the first row in matrix A becomes the first column in its transpose, and likewise the second row becomes the second column and third row third column. So simply swap rows and columns and you have the transpose of a matrix. So now in a position to go through the steps involved in finding the inverse of any 3 by 3 matrix. Firstly, we find the determinant of the matrix, and remember that if we're going to go on from there, then we need, for an inverse to exist, the determinant of the matrix to be non-zero. We need to then find the cofactors of every element and produce what's called the matrix of cofactors. In other words, we're replacing each element with its cofactors. So that will produce a matrix which is A1, A2, A3, B1, B2, B3, and C1, C2, C3, where those, remember, are the cofactors. We then take the transpose of that matrix to produce what's called the adjugates or adjoint of the matrix M. So the adjunct, which is abbreviated as Adj_M, is equal to the transpose of this cofactor matrix. So that will be A1, B1, C1, A2, B2, C2, and A3, B3, C3, where we've taken the rows and turned them into columns. Finally, we divide the adjoint by the determinant of the matrix. So we can say that the inverse of a matrix M inverse is equal to 1 over the determinant of M multiplied by the adjoint of M. So quite a few steps involved in finding the inverse of a 3 by 3 matrix. So let's look at those in practice. So we're going to look at the inverse of this matrix M. So remember that the first thing we're going to do is to check the determinant. There's no point going on if the determinant is 0, so I would always advise you to find the determinant first. We want to check the determinant of M and find its value. Particularly we want to make sure that the determinant is not equal to 0, because that would give us a singular matrix and therefore no inverse. However, the determinant I'm going to find by expanding by the first row. So remember, we're taking each element, multiplying by its cofactor. So 1 has got a cofactor of -14, and then -4 multiplied by its cofactor, which is 20, and 2 multiplied by its cofactor, which is 2. And if you calculate that, you get -90. So remember, the cofactors are produced by looking at, for example, for 1, we've got the determinant of that 2 by 2 matrix there, -2 minus 12 giving the -14. And do remember the pattern that you need to apply to the cofactors to make sure that you get the correct sign for the value of the cofactors. So we've got a value of the determinant -90, and most importantly that is not equal to 0, so we can go ahead and find the inverse of the matrix. To work out that, we need to work out the cofactors of each of the elements. We've already worked out the cofactors of A1, B1 and C1. They were -14, 20 and 2. So we need to do that for all of the other elements. So here they are written out. You might like to check a few of them. In particular, do check that you've got the signs again correct here. So we've got a -1 here and so on. So that pattern of signs that you need to apply every time you're looking at the cofactors. Once you've got the cofactors, we can then take the transpose of the matrix of cofactors to produce what's called the adjunct. So you can see here the matrix of cofactors in effect in the top 3 lines there. So the first row would be -14, 22, and that becomes the first column of the adjunct. And once you've got the adjunct, then divide by the determinant. The determinant was -90, and that's M inverse. If you wanted to check that it is correct, then of course what you could do is find that M inverse multiplied by M and check that indeed that gives you the identity matrix for 3 by 3. Remember also, if it's a numerical example like this, you could enter the matrix into your calculator and work out the inverse and also the determinant in that way. Sometimes, however, we have questions which are not numerical, so they're algebraic in nature. And here's one where we've got a value of k put into the matrix, so it's impossible to do this on a calculator. However, we can still calculate the inverse in exactly the same way. The first thing we want to do is to work out the determinant of A. So spotting that there's a 0 in the second row, we could use that row to expand by and see that if we do that, we get the element 1 multiplied by the determinant, which is -1 minus -2, which is 1, but we want negative of that because of the signs that we need to take, and then plus the other element -1 multiplied by negative of the determinant of the minor for -1, which is -2k, and then plus 3, so it's negative of -2k plus 3, which gives a determinant of 2 minus 2k. If you then go through and work out the cofactors of each of the elements, then you end up with the matrix of cofactors given by this value here, this matrix, so that the adjunct is then the transpose of that. So this here is the adjunct of A, where we've taken the rows and written them as columns in the transpose matrix, and so A inverse is equal to that divided by the determinant. So that concludes this video on inverses of 3 by 3 matrices. In the next one we'll be looking at determinants and transformations.